In this video, we will discuss the problem reverse a linked list in groups of given size. So the problem says that we have been given a linked list which is of n size, so total n number of nodes are there, and the task is to reverse every k nodes from the linked list. And the problem says if the number of nodes is not the last number of nodes that is there, it is not a multiple of k, then we have to also reverse it in the end. So let us understand this with the help of some examples. So let's take the first example. If the linked list is like 1, 2, then it is 3, 4, 5, 6, 7 and 8, and the k value given to us is 4. So in that case we have to reverse the first 4 nodes and the last 4 nodes. So if we reverse it, so it will be like 4, 3, 2, then 1, and then 8, 7, 6 and 5. This is how the new linked list will look like after reversing. Let us discuss the next example that has been given. So if we have been given, let's say 1, 2, 3, 4, 5. So if we have been given 1, then 2, then we have been given 3, then we have been given 4, and then we have been given 5, and we have been suppose given the value k is equal to 3. So in that case, this is one group of size k, but the second group is not of size k. So if it is not of size k, even then we'll reverse it. That is what the problem says. So it will be 3, then 2, then 1, and then 5, and then 4. So we can see here that is the output 3, 2, 1, and then 5, 4. So basically, how can we do it? So one of the things that is pretty much clear is that we always have to reverse in groups of size k. We can keep a counter here, right? We can keep a counter maybe as 0 or 1, and then what we can do is we can try and count. So if the counter is lesser than k, till then, like counter is equal to 0, counter is equal to 1, counter is equal to 2, okay, like this we can do it. And whenever the like we can see counter is equal to 3, then counter is equal to 4. So the moment the counter becomes greater than 4, so if the counter is lesser than if the counter is lesser than this value k, in that case I'll be doing it, otherwise I'll not. So this is one thing. So reversing the linked list is one thing. Let's say if I have been given a basic linked list like 1, 2, 3, and if I have to reverse it, so what is the algorithm for that? So if 1, 2 and 3 is there, and as we discussed, if I have to reverse it, so in that case, like 1, 2, 3 will be there, like pointers will change, and 1 will be pointing to null. Okay, so that means that the previous value of 1 will be null. So I will use what? I will have a previous value declared as null, and current will stand at the head of the linked list. And what we would do here is we would say that we need, like if I directly point this one to this previous, then in that case I would lose the rest of the linked list. So for that, what I'll do is I'll store it in the next variable, and then what we can do is we can say that current's next is equal to previous, and after that previous can get updated to the current, and the current can get updated to the next. Now again same process will follow. First of all, we'll store the next node, and then what we'll do is we'll say that current's next is equal to the previous, and after that again we'll move our previous and the current. So previous moves to this node, previous moves to the current node, and current moves to the next node. Okay, then we'll store the next, then we'll store again the next. So then now the next node is nothing but null. Okay, you can see that. So now first of all we store the next node, then what we do is we mark current's next is equal to the previous, so it points to 2, and then again we update. So previous is equal to the current, so previous moves to 3, and here the previous moves to 3 and current moves to null. So in that case, whenever the current moves to null, then we can stop, and we can see that the head of the new linked list is nothing but the previous. Now the thing is, how do we change the pointers? So let us, like, how do we change the connections? That is one thing. So, and we have to also return the head of the linked list. So what we can do is, let's say we take an example like 1, 2, 3, okay, then we have 4, then we have 5, then we have 6, 7 and 8, and let's say 8 is pointing to null. So in that case, we'll first of all reverse this linked list. So we can assume, like we can see that we will write a function that will first of all reverse the linked list, right? It will also reverse this linked list, it will also reverse this linked list. Now if you understand, so basically I can write a recursive function for myself, and in that function what I can do is I can pass this as the head, okay, and in that case this will be my previous, because if I pass this as the head for this segment of size k, then this will be this is actually the head that I passed, and this is the previous. Now if I have the next node, so this new portion I'll be passing now, this new head I'll be passing, because the current size k, if k is equal to 3 here, so I have taken the first group of size k. Now I need to do next. So my next pointer will tell me that okay, whether or not there is this available or not. So I can say that okay, in that case I can say that this will be the another head that I'll pass. Suppose I'm writing a recursive function, that is why I'm saying this. So this will be the head, and in that case this will be the previous. And similarly for this also, like, so once this is done, so this will be the head, because this is where the next will point after the size of k is equal to 3 is completed. So this is where my previous will point, and this is where my head is going to point. So I can say that my I want what I want my heads next to point to the recursive functions previous, right? I want my heads next to point to something. I want this reverse function to return me the head. So in that case, I'll pass the next node in it, and I'll pass k groups. So it will return me always the previous. So if it returns me the previous, then my heads next points to this previous, and similarly this heads next will start pointing to the previous, and ultimately I'll return this previous, that is nothing but the head of my linked list. So that is what I'm trying to do here. So let us write the code for it and see what happens. Okay, so we have been given the node, so we'll take a node star previous is equal to null. So first of all, we'll initialize the previous to null, and we'll take another node current is equal to head of the linked list. And another thing that we'll take is we'll take the next node. So node star, let's say next node is what I take. And then what we'll do is we'll also take a counter. So int count is equal to 0. Then we'll iterate while the counter is lesser than k, and the current is not equal to null. Till then we'll keep on iterating, and what we will do here is we will basically say that we need to change the connections. So we need to first of all store the next node. So we'll say that the next node is nothing but the currents next. We'll first of all store it, then we'll update the currents next to this thing, to the previous, and then we'll update the previous. So previous is equal to current. Previous will start at the current, and the current will stand at the next node. And after we have done this, so another thing that we need to do is we need to do a count plus plus as well, because we are always checking the counter whether it is lesser than, or if it becomes equal, then I terminate, because the group of size k has been seen. So I need to say that if my next node, right, if my next node exists, if it is not empty, so in that case what we can do, we need to say that our heads next, as we discussed, our heads next needs to point to the previous that this function returns. So I'll say that reverse, and in that case I'll pass the next node comma k. It will return me the head of the new linked list, that is the previous node. And from this node also I need to return the, from this function also I need to return the previous node for my next function. So let us see what happens when we compile this. Is there any error or something? Okay, so we are getting a compilation error. Yeah, I declared it with capital node. I should declare a small node. Okay, next node was not declared inside this, right? So let us fix this. Now let us compile. Seems to work on the samples. Let us try and submit this. So you can see that our solution was able to pass all the test cases, and for solving this problem the time complexity will be order of n. Thank you. In this video we will discuss the problem remove all occurrences of duplicates in a linked list. So the problem says that we'll be given a sorted linked list, and we have to delete all the nodes that have duplicate numbers. So let us try and understand this with the help of an example. Suppose there's a node 1, then 2, then again 2, then 3, then let's say there's a 4, then 4, and then 5. So in this case we can see that 2 is duplicate, right? 2 is occurring more than one time. 4 is also duplicate. So what we have to do is, the problem says that we have to remove all the occurrences of duplicates. So in that case we will say that our linked list pointers will change like this. 1 will point to this 3, and this 3 will point to this 5. So ultimately the linked list would look like 1, 3, and then 5. That is what we have to do in this question. So for doing this, like, let us take the sample example that has been given as well. So if we see the sample example, that is 23, 28, 28, 35. So 23, then we have 28, 28, and then we have 35. After that we have 49, I think 49 again, and then we have 53 and 53. So we can observe here that only two elements are there that are occurring one time. You can see this is occurring two times, this is occurring again, this is 53 is occurring again. So in that case I need to say that like 23 needs to point to this 35, and then 35 needs to point to null. Okay, so basically 23, then 35, and then null. That will be the resultant linked list. So how can I get this thing? So basically for doing this I can use a concept of map as well here. So let us try and see first of all like how I could have done it using a map. So what I could have done is I could have stored the frequency of each and every value. So I can say that 23 is occurring one time, 28 is occurring two times, then 35 is occurring one time, then 49 I can say is occurring two times. Okay, then I can say that 53 is occurring 2 times. So either I can store it beforehand or I can do it normally as well. Like I can see that if I have stored this and if this value is the same, then like you can say, right, if suppose a variable here is there, right, if I've already seen this 28, then if I see this 28 again, so I'll skip it and I'll change the connections like this. So that is what I can do. Or maybe I can do it with frequency. Let's say I come to this, okay, by already storing the data of the linked list. So in that case I can say that if I'm like, if suppose my previous is standing here and I come to, if current node is this, if this is repeating, so whatever number of times it is repeating, I'll skip it and then my current will point to this. Okay, that is how I can change it. But in this approach, the problem is that I'll take order of an extra space. And can we do it without extra space? Yes, we can do it. So what we can do here is, if we observe carefully, so let's suppose that this 23 was also there, right? So like, let us see. So if suppose that this was the, if suppose that this was where my previous was standing and this was my current node. So in that case, this is repeating, right? This segment is repeating. So I need my previous to point to this node, 35. Okay, that is what I want. And similarly, if you observe here, so suppose there was a 23 like this. So if my previous stands here, then I will not be able to check, right? If I mark it like this, then it is not good. So that's why I'll require a dummy variable for me. So I'll have a dummy variable here, initialized to 0. So I'll have a dummy variable here and I'll say that its next will start pointing to the head, such that I will make my previous set here. I'll make my previous standing here and current here. And now I'll try to check. So what I'll check is, while the current is not null, so till then I'll be checking, and I'll check that if the current next that is there, if the current next that is there, if the current next is not equal to null, okay, if it is not null, then I'll check that if the current next data, okay, if the current next data, you have to observe, if the current next data is equal to the previous next data. So is it the same here? No, I don't think so, because the current next data is not, like, if previous next is 23, current next is 28, so they are not the same. So in that case, I will not do anything. But if it is the same, then I will do something. So I'll say that I will do it with while, because if there can be multiple occurrences, right? So it will not happen that current next data and the previous next data is same for one time. It can be same for multiple times. So let's say it is 28, 28, 28. So in that case, these things can happen. Okay. Now what I'll do is, if it is the same, then I'll move my current. But otherwise, if it is not the same, so in that case, what happens? I'll say that now I'll check after I have moved my current if it was the same. So I'll say that if the previous next is equal to the current. So is the previous next equal to the current? Yes, because previous next is 23 and current is exactly standing at this node 23. So the nodes are the same. So in that case, what I'll do is, I'll say that I'll just remove my previous. So previous is equal to previous next. Okay, previous is equal to previous next is what I'll do. And after this, like, I'll have an else part as well, but you can observe, like, previous, if the previous moves to this node, okay, if the previous moves to this node, then the obviously the current will move to the next node. So I will do, at some point of time, I'll do current is equal to current dot next at the end, right? And suppose, like, if I come to this scenario, in that case I can see that the previous next data is equal to the current next data, right? Because 20, like, they are the same. In that case, what I'll do, I'll say that let's move my current. So in that case, I'll say that move my current and do current is equal to current dot, like, current is equal to current next. So move my current. Okay, so in that case, my current moves to this point. Now since my current moves to this point, so what can I do? I want what I want. You can observe, I want what I want, the previous, like, if this is where my current is standing, right? Okay, if this 28 is where my current is standing, and now the current next and the previous next are not the same, because current next is 28, previous next is 35. So what I need to do, I want my previous previous next to point to the current next. Okay, so that is what I'll do, because I can see that the previous next is not equal to current. In that case, I can say that there's some number of repetitive nodes that are there, so I have to skip them. So for that, what I'll do is, I'll say that previous next, okay, is equal to nothing but the current node. Okay, that is what I'll do. So current next, because in that case it points to 35. So once it points to 35, so I'll say that, okay, current will also move here. So now what happens? Current moves to this 35. You can observe, current will move to this 35 and this part will get removed, and you can observe the connections will change like this. Now I can see that the previous next data is 35 and the current next data is 49. So they are not the same. So in that case, I'll move my previous and the current. So now what happens? My previous moves to this 35 and the current moves here, right? Then I can see that previous next is 49 and current next is 49, so they are the same. So I'll move my current by 1, so current moves here. Now I can see that previous next is 49 and current next is 53, so they are not the same. Now what is the, like, in that case I can see that the previous next is not equal to the current, because the previous next is this and the current is standing somewhere else. That means there are some repetitive elements and I need to skip them. So I'll say that previous next, you can understand, previous next is equal to current next, previous next is equal to current next. That is what I'll do. So this part will get removed, and this is where I'll be standing, and I'll like, you can can observe, right? Let me do it. So you can see here. So first of all, I will do what previous next is equal to current next, and then I'll move my current is equal to current next. So current moves to this 53, and this connection gets eroded away. So now this happens. Okay, and this is where my previous is standing. Now previous is standing at this, and current is standing here. So we can easily observe that if the previous is standing here and current is if the current guy is standing here, so we can observe that current next and the previous next are the same. So in that case, we'll move our current. So current moves to the second 53 that is there, right? So since the current moves to the second 53 that is there, so in that case it's not the same. So what do I want? Like I want the previous next to point to this null, and the moment the previous next points to this null, so I'll move my current to the next node, that is this node, and now the current is null. So the moment current becomes null, so in that case I will have to like I can say that the termination is over and I can return. What should I return? You can see here, like this is the linked list, like how it looks like. 0, the dummy node is connected to 23, then it is connected to 35, then it is connected to null. You can observe this. So I'll write it here. So what is happening? There's a dummy node, then with this you have a node connected 23, then we have the 35 node, and then we have the null. Okay, that is what we have. Now the question is expecting us to return this part. The question is expecting us to return the linked list part that is not repeating this part. So for that I can say that if my dummy was initially standing here now, so I can say that if I return nothing but the dummy next, so in that case I like if I return the dummy next, in that case I will be simply able to access the rest of the linked list. Okay, dummy next. Let us try and write the code for this. So what I will be doing here is I'll simply say that I'll have a node star and dummy is equal to new node. So first of all I'll declare a dummy node. Okay, node yeah, so dummy node 0. Okay, then what I'll do is I'll say that node star, I'll have a previous node. So initially like first of all I need to say that dummy next is equal to head. So dummy's next node will be the head, so it will get connected. Okay, then I'll say that the previous will start at the dummy node. Okay, previous will start at the dummy node, and my current node will start at the head, okay, of the linked list. So actual head of the linked list. Then what I'll do is I'll say that while the current is not equal to null, okay, till then I'll keep on iterating. And what I need to check that while the current next, okay, current next is not equal to null, then only I'll be able to check the current next data, right? So if the current next is not equal to null and the current next data is equal to the previous next data, okay, so in that case what do I do? So in that case I'll say that I'll move my current, so current is equal to current next to skip these duplicates. Okay, then I'll be standing after this, I'll be standing at the last duplicate. So if it happens, yeah, we have observed obviously that if the previous next is equal to the current, so in that case if my current is not moving, that means things are perfectly fine, and I need to do what? I need to say that previous is equal to previous next. Okay, so previous can move by 1 because there's no linkage that is changing, because the current variable, the current element that the current node that I'm at is not actually repeating. Okay, otherwise you can see that like you can see that I'll always be doing current is equal to current next, right? But I'll be doing it generically for both, right? I can say that current is equal to current next here, okay, here, and then what I need to do is, otherwise if it is not standing at the same point, in that case what changes I made? I say that the previous next should point to nothing but the currents next. Okay, currents next, that is what I did. And every time at the end I am saying that I'll move my current forward, because even if the current is not repeating, then also current needs to move forward, current needs to move to the current next. Or if the previous, if it is repeating, then the previous next is pointing to the current next, so current will also get updated to current next. Okay, and I can say that what I'll do is I'll change the head of the linked list. So I'll say that head is equal to, the new head is equal to nothing but dummy next, that will be the new head of the linked list, and I can simply return this particular head that I have calculated. Let's try and compile this code to see if it works. Seems to work on the samples. I think it should get accepted. So you can see that our solution was able to pass all the test cases, and the time complexity for this approach is order of n, and the space complexity is order of 1. Now talking about the practice problem. So the first practice problem is add two numbers represented by linked list. The second, like in this, you have to add the numbers, two numbers which are represented by linked list. Okay, so you have to write a function for finding the sum of the linked list, and you have to return it in linked list only. Then what you have to do is you have to find the length of the longest palindrome in a linked list. So we have already discussed how to find the palindrome linked list, and now you have to find the length of the longest palindromic linked list. Okay, another problem is merge case sorted linked list. So this is also very easy problem. Basically, it is inspired from the problem merge, it is inspired from the problem merge case sorted arrays. So basically, in this you will be given to merge case sorted linked list, and you can try this problem out as well. Thank you.